This is my Commodore 64. It's been around almost as long as I have. I take care of it and do repairs as necessary. I still have two fully operational 1541 drives connected to it. This was a big deal 35 years ago. But I also have an SD to IEC because of the convenience of having all of my programs on one SD card. However, it's not fully compatible. I love the design of the case for the SD to IEC. Looks like a 1541 drive. Anyway, I've decided to try out the Pi 1541 and see how well that works. I've ordered the kit from France, and it's one of those assemble-it-yourself deals. The PCB arrives almost completely bare, except for some pieces that are already soldered on. We can see right over there. This is Rev 4 of the board. Note, not every piece needs to be installed for my test. I've got none of the buttons on here, and I should have left the speaker off. Press down on top of the Raspberrypi 3, the build is now complete. Time to see if I still know how to solder. Plug in a serial cable. Plug in the power. I got a green light waiting on the screen now. And there's our screen. Very good. Fire up the old beast. And we're ready to do a quick test. I'll do a directory of what's on the SD card. Very good. And I'll load FB64 now. That worked. Followed by a quick game of quicks. As for a case, I've seen all sorts of creative stuff online, but I wanted to do something different. To that end, I've been eyeballing my data recorder for such a purpose. No, I'm not going to use it. I'm going to use it for inspiration. As part of another learning event in Freecad, I've decided to use this project to try and get into curves more instead of straight lines. This is very 70s futuristic with a lot of curves meeting sharp corners. I could leverage these buttons for the buttons that I'll need for the Raspberry Pi. Also, finding a use for the save and counter functions on the right. Yeah, this is the project I'm going to go with, so it's time to get underway. 1 month later, I was 80% through with my project and very proud of it, until lightning struck and destroyed several pieces of gear in my house, including my backups for this. I'd lost everything, and after being angry for a while, I decided I was going to take out my calipers and use this as a basis for an even better one. But this is not a video going through every single detail of how I built it. This is a video about how you could print out these parts and assemble it yourself. So let's get started. Please watch the entire video and view the parts list before deciding if this project is right for you. This includes extra purchases such as this larger display, these buttons, and this connector kit. We're looking on the main case, we see what's an off-white color, looks a little different under the light. I managed to match this online. Again, I'll provide a link below to this color filament, and that'll cover the outer case and a lot of the pieces. Here I have a PLA silk in silver, sort of has that chrome finish we're looking for right up here, so we'll be using that as well. Black will also be used in several places, as we see. We got this border logo and these labels and this counter right here, so that's black. We have white filament. It'll only be used for one reason on this project, and that's for these white numbers over here. Just decoration. Brown arrives tomorrow, but this is a stand-in just to represent brown, and that'll be for the buttons below. This is obviously a copper silk. I'm not going to use it. Now it's tomorrow, and brown has arrived. First order of business is to wash the platter. We're going to be working with a couple of crazy angles, and if it doesn't adhere, it's going to be a mess, and use soap. So we got some hot water, got the platter wet. I'm just going to move my hand around to get all the grease and oil off, distribute that soap. Then I'm going to use hot water again to wash off the platter completely. The water just kind of sticks to it when it's clean. It doesn't bead off. The other side sort of beads off a bit. You see that's beading off. That doesn't. So the platter's looking good. Now I'll dry it with a clean paper towel. And it doesn't matter if it leaves microscopic paper towel particles behind. Still going to adhere. It's just fine. And I'll clean the bottom too. Make sure that's not wet before I put it back in the printer. And this platter's ready to go as long as I don't touch it. Drop it back in, but not like I did. Put it in straight. The pieces have been distributed on 8 separate plates as shown. Just makes it easier to work with. And our first piece is going to be the bottom portion. It's one of the bigger pieces, but it is an easy print. There's no crazy angles or any trickery. We're going to have a view here in a 3D. Not an overly complicated part. but a lot of different pieces built into it. Every part here has been pre-configured for colors as well as special settings. If you want to play around and change them, by all means, but I've already set these up in what I feel to be the optimal setup. The only reason why we're using supports are for these two areas right here, just to keep things smooth. Other than that, pretty straightforward. Make my way over to print. I'm going to turn auto bed leveling on because why not in a final build. I'm also going to use time lapse for my YouTube video. And we're going to make sure that I'm using the right color in the right area of the AMS, and that's slot 2 for that off-white. Make sure you're going to print it the wrong color, and then I'm going to hit send. That's my off-white in slot 2. I always like to monitor the first layer on the big projects. After that, I just let it run off and do its own thing. And I won't go into this kind of detail on every part, just this first one, or wherever necessary. Pull it off the bed, and it came out clean as I pull this off, except for one little nub right here, and I'll remove that with the razor. Everything else looks really good, came out nice. We'll move on to the next part. Now this is the top half, and it's set up a bit different. It's got a brace holding it up, and it's on an angle. The reason is it would look terrible if I printed it flat. If I laid it down, it'd be supports all over the perimeter because it's curved. Very hard to work with those curves like this. So I have it on an angle. I've set up the threshold for 45 degrees. I'll show you why. Not only do I have that support on the bottom with the extra rafts, but the supports also support in the center section, which stabilizes it and it doesn't look all distorted when it prints. I'll print it now. Again, making sure that the color's correct. Auto leveling definitely has to be on for this print. Time lapse doesn't matter, so we hit send. This one looks particularly interesting as it prints on an angle, but we can see the sides are nice and smooth, and the top facing area is also going to be nice and smooth. We're only going to have to deal with one portion of it. So I'm going to pull it off now as it's finished. Remove these supports that are stuck together right here. Just break it to release it. Pull the other one out. That came out nice. Flip it over and we could see that I have this extra support that I added into the model here. Peeling away the raft from it, I just bend it forward and it should snap right off. Almost clean. We'll address that later. You see? Now we'll pull off this raft right here. And we can see this is like the ugly portion. But no worries. This is all going to be taken care of. Taking a straight razor, I'll clean these raised areas. These are not going to be visible. They're covered. But I still want them flat so it doesn't warp the material that's going to be sitting above it. So just shave it down to the plastic. Good enough. That looks fine. So we're going to move on to this other piece now. And I just want to cut any of the raised areas in this distorted looking area. I don't want to go outside that area and scratch any of the smooth areas. I said areas a lot. This side now, just going to cut this piece off right over here so it's not sticking out and everything is flat. And that's all I'm going to do. I'm not going to pay any more attention to it. That's good. Now we'll move on to the next step. Detents exist on both sides so that the pieces can snap together. We can see some debris right here on the top side that's going to have to be removed so everything fits properly. Snapping it and removing it a couple of times will seat those tabs by wearing them down and make for a good fit. And so now we move on to the next piece. This piece is going to be the tape overlay, and this is a 2-color piece. Unfortunately, without AMS, there's no way to get that second color because it's just a stripe in the middle. So we can see right there. So this is one of those things, if you don't have an AMS, you're just going to be printing it in the gray. So I'll be adding black to 3, and the gray silk will be added to 4. Then I'll go in and update my device settings to match what I've just added. That's the black one. In 4, I'll add the gray silk. With that out of the way, I could print the part. Always assuring that the colors match up to the parts as we see here, so that's good. Leveling on. Just going to hit send. It came out nice, but the chrome is a bit flashy and gaudy for my design. So I think what I'm going to do is reprint it in silver. That's a lot better. It no longer looks like Liberace's tape recorder. Has a little bit of a shine to it, but it doesn't jump out at you. We're going to go with that. Our 4th plate will consist of a couple of pieces, and all of these pieces are going to be printed in black. Nothing special about this one, no special settings, so we're just going to jump right into it. making sure that I'm on the black rolls number 3, turn on auto leveling, and then hit send. We'll detach these outside the printer. First, I'll remove these 4 little feet one at a time, make sure they don't fly anywhere. Now the remaining piece is very thin and delicate, so it needs to be taken off carefully. Perhaps maybe with one of those plastic razors. But if not, I'm able to use my fingernail and gently pry up a corner as to not bend the piece, just to release it, move over, release a little bit more. And when I have enough released, I can grab it from the middle portion and lift it right off. No damage. We can see how unbelievably thin that is. Came out nice. I'll place these items down in my completed area. These pieces will be immediately assembled. As I turn this around, there's a detent in here. It's a little deeper. One side is thicker than the other. If I turn this piece around, we can see the finished side's pointed up. I get it around all the holes very delicately and press it down into that detent so it's in position. Everything here should now be flush, which it is. Nice and flush. That's enough for now. We'll move on to the next portion. And this is the bottom of the bottom shell. We're going to press those feet in to all 4 corners. It's a nice fit, so it'll hold without any glue. All the feet are in. We can put this piece back down and move on to the next step. Now we're on our 5th plate. Nothing special here. We're going to be printing it in that off-white color. Slice and print. Settings are ready. And you can see I messed up because I'm printing it on my white roll in A1 instead of A2. But I caught the mistake before it started. These pieces are done. We'll just take them out and bring them to the table. We'll move on back to printing. We're making our way to plate 6 right now. And if you have an AMS, there's really nothing special about this. They've got 3 pieces, different colors. You could hit slice plate and print it, and that's it. If you don't have AMS, this is what you can do. You could go to the piece that you're not printing. We're going to print this one. So we're going to go to this one and uncheck printable. Go to this one. Also uncheck printable. And now we're essentially working with one part. We hit slice. And the bar on the side, we're going to roll down until the black disappears. And then one more. We could see that's where it appears. We'll come back down. And right over there on 8, we're going to click it and hit add pause. And that will stop the printing, allowing you to change the filament to black, and then hit continue, printing it just like this. We're not going to do all that though, so I'm going to re-enable these parts because we don't have to do this with AMS. But I did realize they are the wrong color. These in fact should be silver, so I'm just going to fix that now in the middle of the video, and that'll be saved. They're now silver and black. Slicing. Verifying now, the 3 colors we'll be printing for this event. This is 1, 3, and 4 on mine. So I can hit send. Auto leveling is on. These pieces are completed. Definitely needs a configuration change on the print, but they came out nice. We can see a little deformity on the top right, which I've already addressed as I make this video. This one as well would also improve. Holding the top bezel facing up, the check mark should point to the left like this. From behind, it should just snap in, and we'll do so even better with the configuration changes I've made. I'll talk about that in a second. This will be followed by the insertion of the Commodore logo, also snapping into position in the same fashion. Should hear an audible click. This piece is finished for now. We'll put it down, and we're going to pick up this plastic piece right here. It's a rectangle, got that hole in it. With the hole to the right, as shown, we'll take that panel with the numbers on it, numbers facing up. We'll put it in and snap it into position like we did the other 2 pieces. Hearing that audible click, putting it back down on the pile. This piece is done for now. I've taken this panel and removed the number piece and put it into a new panel, much more efficient to print and a lot less transitions, so less distortion. We move to the next panel, and that is the top logo cap. This will only print multicolor with AMS, so if you don't have AMS, it'll just print that singular color. But for AMS, it's a black logo with silver stripe or pretty much whatever you want. And I'll apologize beforehand, with 3 colors at this angle, it is not a quick nor is it an efficient print. I'll hit print and make sure all 3 colors match up here on the configuration. Auto bed leveling is critical on this one, time-lapse optional, and then I'll hit send. I glued these 3 pieces together to see if it was worth gluing. Turns out it wasn't, so don't do it. Installing the bezel on top of the cover, I line up those 4 pegs that are very delicate, and using my thumb to secure it, I push down on the bottom and lock in these pins. But now I need to make sure that that bezel, that black piece, is fully on the inside of that perimeter, because everything's glued together so there's no grace or movement. So it was a little more difficult to install this, but it still came out good. A reminder not to glue those pieces. Not only can the glue raise the areas that need to be flush, it just makes it harder to install because, again, like I said, there is some wiggle room to install all these without glue. But that piece still came out nice. We're going to move on to the next step. The end cap has now finished, so I delicately remove it from the printer. And I'll tell you, this printed really nice when it was monochrome, and as I remove it, I could see in the transitions that it was somewhat weakened. Those little pins don't look as good as I want them to. I may have to make an adjustment here for that. So I'll apply any changes to the project after testing, but I have 3 good pins, and that's enough to do the job. So I'm going to continue with this. Need to clean off the bottom, though, with a razor. So I'm just going to dress that up. I could have used sandpaper on a flat board to dress it up since it's flat, but still, it came out okay. This piece then snaps right into the 4 holes up top. You can hear an audible click as they do. And that portion is now completed. Depending on how well it sits in there, you may elect to glue it or not. I should not have, since I'm actively testing that piece for reprint. But no big deal. It still came out nice. That piece needs a little adjustment, but we'll move on. The settings were refactored later, and the print came out a lot better. Here is the larger screen that I mentioned earlier. This one's had quite a workout since it was used for development. Removing the plastic film, I gently place it over those 4 pins that are protruding and lock it down. It should just seat without any resistance. These 2 brackets that were printed earlier should snap right over the holes. One side is beveled to make it easier to get around the pin. So we snap it in, squeezing everything together from the top bezel to the bottom holder as I do, repeating the same process on the other side, so everything from the top bezel all the way to these pieces are tight together. These 4 pins are in fact super glued in, so a little dab of glue right here where they meet is sufficient to do the job. Make sure everything is still pushed together before the glue dries, or you can do some reprinting. Everything is secured, the screen, the bezel, all together now. Screen looks nice, so we're going to put this piece down and continue with the next step. Brown replaces white in slot 1, after which I will update AMS to reflect that change. This brings us to the last plate, the 5 buttons. We'll just be doing a slice and print on this plate, ensuring that we use our new slot that we put the brown in to do so. So I'll hit the slice button, then print. Make sure we're in the right slot, slot 1, auto leveling's on, I send it off. While that's printing, this piece right here will go into the square hole. This is the one with the numbers on it, such that when you place it in, the numbers are facing upwards. I'm just going to push and snap that in. We hear that audible snap. And that's it. The super glue will then be used on the piece that we just installed, as well as that black piece that went into the center frame, gluing everything down. Not too much glue, we don't want to get it anywhere, just in the seams right here. That portion is now done. We'll put this off to the side and move on. The last piece is rolling off the printer, concluding our printing. It's now time for assembly. The Raspberry Pi will be installed in the bottom of the case, and we'll be using 2.5 by 10 mil plus 6 mil standoffs. You could opt for brass of the same dimension. We'll also require 2.5 by 6 mil screws, just like that. I'll pull the SD card from the Raspberry Pi and just lay it right down in position, the slot obviously facing the slot hole. All the holes should line up. These standoffs can be installed with the fingers, no problem at all. Since I've done this 50 times this month, I'm using a driver though. But if I was just doing it once, I wouldn't require the driver. The tolerance they were printed at makes it pretty effortless to put in. The holes in the Raspberry Pi are slightly oversized, allowing for a little bit of grace, so you can move it back and forth to center that SD card if you wish. Holding the Pi into position and then tightening down the front 2 screws once it's perfectly centered. This is followed by the back screws, which could be snugged down. Remember, not too hard, it is plastic. That looks good, so we'll try inserting the SD card. Goes in with no problem, good clearance. Pulling it out after that with the fingernail, getting it started, drops right out. And then subsequently I'll just put it back in permanently for this build. With that installed, I'll do a quick test fit of the Pi 1541, pushing down to fully seat it. Everything lines up nice. Everything looks good there on the serial, here on the power, and there on the card slot. I'd like to go over the only things that should be installed on the Pi 1541 at this time. This includes R1 and R2, as well as R3 and 4, this IC, this capacitor, these 2 jumpers with speaker enable jumped, these 2 serial connectors, the display header, though shown as not yet installed, and if we flip the board over, the header on the bottom. Note that I accidentally damaged a pad while removing an LED from testing, so I'll be bridging it to that resistor. I wanted to point that out now. I'll also quickly go over the configuration blobs that I used. J9 is in the top position. J5 through 8 also in the top position. Voltage is bottom 3.3. Board pinout is left, ground VCC. And the bus is both left for 0. When looking at the front panel for the buttons, we will see that the order that they're in is inverted because the board is flipped around. So left to right is right to left when the buttons go in this bracket here. Here are my buttons from the link provided below. These came with wires pre-soldered onto them, which proved to be advantageous. And I'll start by removing the associated hardware from each button. There's a nut and a washer. We'll be reusing the nut, but not the washer. Each button placed into the bracket with the nut tightened down securely. Once it's finger tight, you can elect to tighten it a bit further with a pair of needle nose pliers. But once it is fully tightened down, ensure to rotate the nut such that it is parallel with this slot and does not impede it in any way. After which blue Loctite is applied to the threads all around, and this piece reaches its stopping point, left to dry overnight. This wire right here can be tied to all the other grounds, reducing 4 wires from this setup. We'll bridge it all across to this wire, and this will actually go to the board, so we'll only need 5 cables. So what I'm going to do is start slicing away at the shrink wrap for the black cables. Kind of off camera, you get the point. Remove the shrink wrap, just like that. Now I have it removed off of all 4. On that first one, what I'm going to do is remove all of the insulation entirely. I could have in fact just desoldered this cable and used a solid copper cable to bridge across, but this is just what I did. Spun around and twisted nice and tight, this cable is ready to go around all the other connections. The 3 black cables in the middle are no longer needed, so I'm going to remove them one by one. Now I just spin that bare cable around a post and tighten, then I'll just solder it on, move on to the next post, and do the same thing, until I make my way to the final post, where I'll wrap it around the existing black wire and the post and solder it on. Then I'll just clip off the excess. This is completed. The remaining wires will be terminated with the connectors that I have in the Dupont kit. We're going to put female connectors with singles on them. Pulling them off one at a time from this strand by bending them back and forth. I'll open up the supplied crimper and inserting it in to match up with the detents, I'll lock it down only until it touches the bottom, no further. The first cable is then inserted until the insulation bottoms out, squeezing down all the way till the crimper opens. I assist the removal of the pin, and this pin is now perfectly crimped. The plastic shield is locked over and snaps into position, completing the end of this cable. The other cables are done in this exact same fashion, and then the end caps are placed on and locked in. terminating 2 colored wires from the kit. We'll keep track of the colors. I've separated them slightly. And this is somewhat tedious because what I'm going to do is wrap around those ends off these tiny little terminals. This is just the way it came out with the available room to do so, but they are easy to solder. I've applied flux first. I had initially elected to tin the cables. I don't recommend doing this because it makes them too rigid to wrap around those posts. I did, however, manage to wrap them around and solder them. The pin should be bent slightly outward such that this separator is able to fit in between them. The button is then dropped squarely into the hole. Brackets then pressed down over the button, locked into the top cover, and the front piece sits separating the 2 wires. Just like that. Glue is then applied right here where it connects to the top cover. Just a little bit is fine. Also right under here at this separator piece on the black piece. I push it down to hold everything together. Now we can give it a test. It's working good. When all of the cables are done up top, a stress relief will be applied right over here. Another pair of wires are terminated. This is gray and white. And this is the speaker. There's no indication of what the polarity is, and mine did not come with a sticker, so it's going to be hit and miss, 50-50. Either way, I'm going to wrap the wires around each of the legs. I'm going to solder it. It can now be installed in the top cover. So I'll drop it right in the hole over here. It'll seat right in and direct the angle of the wire towards that stress relief where the other wire is. Just about like that. Small amount of glue is then added onto each side here to hold it in a position. And that part is now done. Next we'll be installing the LEDs. It starts with this small panel that we're going to snap into the hole. It fits just like the other one. A small amount of glue is then applied to a couple of the sides. Looks good. My LEDs were previously installed so both legs are the same size. It really doesn't matter. If the polarity is wrong, you could just reverse it once it's installed. Here are the 2 sets of cables I'll be needing. And we're just going to tie these leads off to the LEDs and solder them on. Then clip off the excess. This one's completed. We'll do the other one in the same fashion. The LEDs will then be inserted in the holes and cantered towards the other wires to match that stress relief location. Drop the other one in, do the same thing. With that angle set, they'll both be glued into place with a little bit of glue. The pins are then bent down towards the direction of the cables to reduce the overall stress and provide more room. They shouldn't come any higher than this bracket. Things are looking real nice up front now. What we're going to do is apply the stress relief, so a very small cable tie goes through the loop, through all of the wires. Brought nice and tight, so everything is bunched together, making sure there's no stress on the connectors, because the wires could still be moved at this point into position. Snip off the end, and apply a liberal amount of glue around the cable tie, so everything gets glued together, so that pulling on there will no longer affect the connectors. I'll spray that now to dry it. Bending them upwards now does not affect the bundle on the left, so the stress relief is good. A female-to-female 4-cable connection has been terminated, and this will go onto the LCD display, completing our wiring work of the top cover. Jordan from the future here. There's not a whole lot of room to work, so where I could take these 4 individual ones, remove the black shielding from all of them, and then put on one of the pieces that holds all 4, it'll make it more rigid and easier to install later. Other areas that could be improved in this manner include the 2 wires for the LEDs. There are 2 sets, and you could put a double on there. Now we'll continue. Removing the Pi 1541 off of the Raspberry Pi so we can work on it separately, I'll need to install the corresponding pins into all of the holes. But we can't connect anything until we test the buttons. Simple continuity test between ground and each one of these red cables. I'm going to connect my meter. It's set to diode, and I'm just going to push the button and hear an audible beep. Repeating this for all 5 buttons. Now, one by one, I'll set up each pin I want to install. Support the top end with masking tape onto the board so everything stays together. Then solder in the pins. That looks good. I'll do all the rest of them. This one right here will be the special repair. And it tested good. This side I put the ground and the positive. And then subsequently all of the other positives were installed for the buttons. I've got reset installed, the LEDs, header for the display, as well as the speaker. The board is now reinstalled onto the Raspberry Pi, and then it will be screwed in with the 4 screws. With a final gentle snug on each one. Testing my connections now, I'm going to start with the display, and I know it has to be spun 180 degrees because it's inverted. Plugging it in, I'll apply power, and it should light up. Looking good, we'll move on to the next. Checking the green LED power light now. It did not come on, probably inverted, so I'm just going to go and flip it around. Now the light came on, so we'll test the other LED off the power light, and that one's good. A quick test of the button functionality will be conducted, so I'll wire them in right now. This first post getting the positive and negative, and then subsequently all the other posts just getting the positive. Using these directions as a guide, I'm just going to go through right quick and make sure that the buttons are all working. We can see that that's okay, and then we got up, and we got down, then we got back, and the plus would not work in this example right now. These holes will point towards the middle of the unit as I install it and snap it into place. Verifying again once I get it all the way into position that those holes are pointed up towards these signs. And then I'm going to glue it into position. So make sure it's perfectly seated correctly before you glue it. There's no going back. I'll wire them in once again, along with the LEDs, the speaker, as well as the reset button. The screen already being connected. I'm not going to close it yet. I want to go through one more test, going through all these buttons, checking the lights. This reset button I didn't check before, that works. Then I give it a quick test on the Commodore, now giving it one last visual inspection before I close up the box for good. Locking in that first side without the serial first, and then snapping down the serial side. The box is now closed. The final pieces, the button caps, have little appendages at the end from the printing. It's an artifact. Make sure that they are completely scraped off on those corners, or it's going to bind when you install it. Pushing in the first one, everything's fine, and I'm not using glue to do this test fit. Make sure everything fits nice before we do the glue, which I'm now doing with a little dot on top of the button, and reinstalling the buttons one at a time, pushing down all the way to make sure the glue sets. Now repeat this. This concludes the assembly. Personally, I'm very happy with this tribute to the Commodore data recorder. Let's go try it out. I'll plug in my serial, which can be daisy-chained on this unit, followed by power. I wish there was a switch for power on the Raspberry Pi 3, but there is not. Fire up the computer. The flicker is due to the refresh and should be disregarded for this video. I've tried to minimize it, but I'm going to navigate the menu down to Games and find a suitable game that I'm going to use for this test. Choosing Bruce Lee, I hit load as if we inserted the disk in the drive. Starting with a quick disk directory, everything looks good, so we'll load the program and see how everything reacts. We'll shift back to the unit to see the beeps and the display. That beep is supposed to be the tick every time it switches tracks. Our activity light lights up just like the disk drive, and we can see what track we're on right here. I'm going to speed things up because it's notoriously slow to watch this. But at 4 times the speed, you can watch the tracks count down. On this particular disk, we'll stop at track 11, having loaded the software. I haven't put Jiffy DOS on here yet, but good enough for a test. We finished and the red light has gone out. And so we run it, just like any other software we've loaded off a disk. Again, I'm not going to make everybody watch all this. This is just a demonstration of functionality. I'll admit I was tempted to stop and play Bruce Lee for a while. Hitting reset removes the disk and takes you back to your default home directory, which I haven't yet configured in the configuration, and that's fine. And I could go through a million games. That's not what we're here to do, just to demonstrate how it works, and it seems to be working great. I've ended up with the case that I wanted. You're welcome to print it out too and enjoy it for yourself. This has been a wonderful and challenging experience learning some new features in Freecad. I hope everybody's enjoyed watching this video, and I hope you'll print one of your own. But that concludes this video. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button to be informed of more videos like this when they come out. I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?